Ladies and gentlemen, a very good morning to you all. On behalf of Dr. NGR Educational and Research Institute, it's my privilege and to warmly welcome you all to the Professional Society event on blockchain, the backbone of decentralized systems. We are delighted to see such enthusiastic participation from academians. It's now privilege to invite Mrs. Agalya, Assistant Professor, Department of Information Technology, to introduce our esteemed chief guest, Dr. M. Robinson Joel, Associate Professor, Department of Computer Science and Engineering, KCG College of Technology, Chennai.
Good morning to everyone present here. It's my privilege to introduce our esteemed chief guest for today's Professional Society event on blockchain, the backbone of decentralized systems. Dr. M. Robinson Joel is an associate professor in the Department of Computer Science and Engineering at KCG College of Technology, Chennai. He earned his PhD in Computer Science and Engineering from Manonmaniam Sundaranar University, Tirunelveli, and has over 20 years of teaching and research experience. A distinguished researcher, Dr. Joel has contributed extensively to the academic community with 10 SCI journal papers, 10 Scopus Index journal articles, 23 IEEE conference publications, 2 Springer conference papers, and 33 Scopus Index book chapters. He has also authored 3 books and published 2 patents. In addition, he serves as a reviewer for several reputed international journals. His research interest includes image processing, machine learning, web mining, big data analytics, information retrieval, and artificial intelligence. We are honored to have such an accomplished academician and researcher with us today to share his expertise on blockchain technology and decentralized system. On behalf of Department of Information Technology and the Association of Information Technovansa (AITSA), I extend a warm welcome to Dr. M. Robinson Joel. With great pleasure, I invite Dr. M. Robinson Joel to share his valuable insight with us.
We are, we are honored to have Dr. M. Robinson Joel with us today. I now request our esteemed chief guest to kindly deliver the address on blockchain, the backbone of decentralized system. Welcome, sir, and the stage is yours, sir.
So, good morning to one and all, and I especially thanks the management, Dr. India University, and the Department of IT, HOD, and each and every staff members for giving this golden opportunity to have a knowledge sharing about blockchain, the backbone of decentralized system. So, my name is, as said, my name is Robinson Joya. So, what is a block? First of all, we have to break the title. What is blockchain? So, what is a block? So, the block in a hard disk. Already we learned about what is hard disk. In a hard disk, there is a physical sectors. It is a physical location, uh, which is called a sector. It may be a 512 bytes or 498 bytes, and these sectors are combined together to form a name called block. So the blockchain is extracted from this block of a memory unit. So this block are combined together to form a chain with a chain, and it is called as blockchain. Okay. So this is a hard disk. So in this disk, the location is called a block. So they may call us a bad sector, black block. A number of blocks are available. These blocks are very bad sectors, like that they will say. So this is a block. From this block, each and every block are connected with a chain or a memory. The chain in the sense it is a memory address to one block to another block. So this is called as a blockchain. This is the basic concept of a blockchain. Before going to what is blockchain, this is the concept. So in a memory, there is a sector called, in a hard disk or memory, it's a sector called block. These blocks are connected via a memory unit, a memory address from one block to another block. So they are called as a blockchain. Okay. So what is a blockchain in a theoretical manner? It is a decentralized and distributed digital ledger. A ledger, you may come across this word in a banking sector. So it's a ledger. Or in a database system, DBMS system, they will call it as a log file. Whenever a transaction happen in an ATM machine, they will say a log will be created for each and every transactions. Okay, so these logs are in term named as a ledger in a banking sector. So it is a decentralized and distributed digital ledger that records transaction in a, first of all, secure and transparent and immutable and chronological manner through a cryptography mechanism. So from the name, it is a secured one, blockchain, and it is a transparent one, and it is a mutable in the sense whenever you created a block, that means if you are trying to load a data or a image or our file into a block and it is secured, that one it cannot be changed unless or we have a key or a hash function to crack the particular block and take the image and resubmit it to another file. Otherwise, it is not able to be mutable. It is immutable one, and it is an order, chronological order. That is called as a tree structure, or in a data structure, they will try the tree structure. So this is a secure, transparent, and immutable and chronological order. So traditional centralized system. What is a traditional centralized system? Before blockchain, we have a traditional centralized system. In our country itself, there is a centralized system only. And for example, in a political manner, they will say it is a central government and a state government. And the money was central government give some tax amount to a state government, central government from a state government, and the cumulative amount was shared among all the states, irrespective of the amount given by the state. Okay, so this is a centralization. This is the issue between, for example, if you give a 1,000 rupees to a central, the return money we will get is only 500 rupees or 600 rupees. Even though we paid 1,000 rupees to a central, the amount given to a state after the cumulative amounts collected from the states, the central will provide only 500 rupees or 600 rupees. So this is the issues in a centralized system, okay, in a political manner. But in a system manner, a data or control are managed by a single central authority. So one person or a one unit will control all the system. So this is the issue in a centralized system. All users depend on the central server. All data are depend on a central server. Okay, so there is a manager, there is a boss. He acts as a boss. He will give all the um, thing to do. He have the hold, he have the key, or he have the authorized person, and he will say you deserve this amount of salary for you for this month, and this is the salary for you for this month, like that. He act as a boss. Okay, so this is the issue in a centralized system. For example, in a banking system, the banking database or client server system, it is a single point of failure. Suppose there is what is the limitation here? For example, if uh, take it as your example. For example, your mobile, you have a photo. Okay? Suppose your mobile was lost means your photo will stored in the memory address, memory slot or in a mobile data storage system, then it will be failed. So instead, what we are doing, we are just copying the photo into a Google photo. Okay. Suppose the photo taken by the mobile phone was shared in a Google photo via your Google account, then whenever you need, you can take it from anywhere else, in India or in Malaysia or in Singapore or in America. You can take the photo. So it is a distributed system or it is a decentralized system. Okay. So when there is a single point of memory means the failure will occur and the failure will cause a lost. Then security and vulnerability. We can easily crack. For example, if you are giving the mobile to a shopkeeper to repair, they can able to visualize or view their photos and they can able to copy. So before giving to a shopkeeper, you have to be a secure. You have to secure something and don't use them if you have an unshareable data in your mobile phone. Okay, so it is a highly operational cost. So cost will be very high since we are trying to maintain a centralized system with secure, okay, lot of security apps you have to use like that. So it is a high cost and lack of transparency. Here the transparency also missing. We can't able to ask your boss whether what is happening. Okay, we can't ask what amount you paid on this particular issues or like that. We can't able to question their boss. Okay, so these type of things are occur when we go for a traditional system. Okay. So limitation, as I said earlier, it's a single point of failure. So it is a central server or it is a local. So power outage, natural disaster, or a cyber attack, entire system may be become unavailable. Okay, for example, in a banking system, this concept will be available. Okay, withdraw money from an ATM or perform a transaction until a server is restored. So service downtime, uh, you may come across this message from 12 p.m. to 3 p.m. or 2 p.m. We have a service maintenance time. So don't do any transaction during this particular time. Like that, they will give some message, you know. So this will be occur when we have a centralized system. Okay. So customer will not trust with your banking system. Okay. And then security vulnerability in a central system, all critical data is stored in a single location. So the single location is the major problem. So if you are saving, any person can attack your valuable data. So cyber criminals, malicious insights. So for this reason only, the cyber crime police will regularly warning us: don't share any valuable data with or valuable key with your unwanted phone calls. Okay, so these are hackers they normally do. For example, in a medical field, it is very vulnerable records. So the patient records are very valuable records. No need to share with that particular data and the personal information of millions of users. Okay. Nowadays, WAN is very sensitive and the data is stolen very easily. And we are the only person we are happily share the data with others, knowing or unknowingly. Okay, we didn't read any that copyright forms or whatever maybe. We just click that one and we will say, okay, take all my data and you can use it like that. We will do. We need only the app, not our security. So people are very much interested, but our data was really hacked, and I literally say to my students, don't share your photos anywhere uh, because your photo may be hacked, and nowadays the AI is very much uh, useful. They use our photos in a different ways. Okay, then high operational cost. So the operation cost is very high, and we have to consult with hardware, software, security systems, networking equipment, skilled persons to maintain all these networking equipments or security issues. We need a skilled persons. So To avoid these type of things, we are going for a blockchain. Okay? So example, in e-commerce, for example, Flipkart, Amazon, they are going for this blockchain concept. Okay? So their data will be very much secure one. They need to, the payment issues are will happen. And lack of transparency. User must trust the central authority because they generally cannot independently verify how data is stored or modified or processed. So data manipulation may go unnoticed. SSA is an organization boss. He is controlling all the thing. So in a traditional distributed system or centralized system, these are the major thing, four major thing happening. So especially in a financial system, so don't need to go for a traditional centralized system. So we need to go for a uh, blockchain concept. Okay. So what is a distributed system? That is a centralized system, and it is the same concept is a distributed system. But here we are distributing, even though there is a centralized system, we are distributing the data into some different nodes. Nodes in the sense it may be a computer or a mobile or whatever may be. In some places they will say cloud concept. Okay, cloud is also one type of this distributed system. So distributed system is a collection of multiple interconnected computers that is also known as nodes that work together to perform tasks and provide service in a single uniform system. Okay. So what are the key characteristics of this distributed system? It's the data processing in distributed among multiple computers, improved performance, improved fault tolerance, and scalability. And what is decentralized system? Okay. So we learned about what is distributed system, what is centralized system, and what are the drawbacks in the centralized system. Now we are going to see what is decentralized system, or in turn it is called as a blockchain based system. So here there is no central authority, there is no boss here. Every user or every node became a boss. Okay. So you and me became a boss, just like in a normal employment, there is a boss. When you became an entrepreneur, you became a boss, and you have all the uh, thing to control your time of resources or your personal resources or your company resources like that. So you are becoming a boss. So the boss system or the central authority system was break in the blockchain uh, decentralized system. Okay, then multiple nodes share responsibility. Here, what is the problem is the multiple nodes become so responsible, so they have to be very careful while sharing. Data is validated through consensus mechanism. Okay, so we need to have a consensus whether I have to share the data with others or not. So before I am sharing, I need to get the key. Okay, I need to get the OTP, whatever may be. Okay, with some type of security, we have to open the data. Okay, via OTP concept or via any um, keywords, key for opening the data from one system to another. Okay. What is the advantage? Here, the increased reliability will increase, enhanced transparency will be there, reduced dependency on intermediaries. Okay, there is no intermediator between boss and employee. Okay, there is no HR. Okay, we all became a boss, so there is no HR there. So it is a transparency and no intermediaries, better security and trust. Okay, so transparency lead to a security and trust. That's all. Okay. So, blockchain as a backbone of a decentralized system, the same slide what I already showed. Here, the secure, the transparent, and direct interaction will plays an important role in a blockchain when we go for a decentralized system. That is a blockchain concept. Okay? So, secure, transparent, and direct interaction. Okay? There is a boss, but we have there is no need to boss. We will directly interact with the memory unit or the central system to retrieve our data, and we can store our data in a particular block whenever we need a secure system. Okay, so when you are going for a transaction with a e-commerce system or transaction with a hospital, if there is a blockchain means we can trustfully we can share. Otherwise, did go to an intermediate. Okay. So what is intermediate? What you understand from intermediate, I don't know, but I have to explain with a small example. For example, when we are nowadays there is a concept of FASTag in roadways. Okay. When we are using a highway, there is a FASTag. In traditional system, in 5 or 10 years back, they have a system called they have to need to pay the amount in a cash as a cash. Okay. So we are paying as a cash. While we are paying as a cash, we know that this particular toll have 35 rupees amount. Okay. The next toll it is a 65 rupees. Okay. Like that we know it. Okay. But when transaction through FASTag comes, a company or a bank they are holding this uh, FASTag as a intermediator. Okay. For example, HDFC Bank. So we are paying. For example, we are loading our FASTag account with 1,000 rupees. Okay, while we are trying to call it is a long journey to Kanyakumari means we will pay advance amount of 1,000 rupees to the FASTag. The amount will not directly go to the FASTag National Highway Department. It will go to a hub of a bank, and that bank will act as an intermediator to the national highway. So there is an intermediator, or there is a boss, or there is an intermediator between us and the national highways. Okay. If there is a blockchain, means it is directly go to the uh, national highway. So there is an accountability, there will be a transparency. Okay, he can easily say this is the amount you spent, even though there is a message will come that you cross this particular toll with this amount, but it is happens via a bank statements. Okay, so this is a thing. So it's a distributed ledger, cryptography, security, and consensus mechanism. Okay. So what is peer-to-peer communication? In a blockchain, it is a peer-to-peer communication. So here the peer it is denoted as a node, okay, or a computer. Communication is a network model in which participants, that is nodes, communicate directly with one another without the need of a central server. Okay, so this is called peer to peer. Peer in the sense, suppose we are downloading an image. Okay. Ultimately, we became a peer or we became a seed to particular domain. Okay. In a computer networking, we became a peer or a seed. Okay. Why we are calling as peer or seed? There is no centralized system. If another person is downloading the same movie, means the data will transfer not from a centralized system, but from our system it is the data will be transferred to the particular person via our from our. So we became a peer or we became a seed. Okay, this is a concept of a cloud and this is a thing of a blockchain also. So to avoid the central server. So traditional system, there is a user, there is a central system and user B. So user A, if need a data from a user B, there is a concept of central server. Okay, server concept is that in older versions or in traditional days, near 15 years back, they will say there is a server. Okay, now there is no server. All are centralized. All communication passes through a central authority. Whereas in a blockchain-based P2P, each and every user became a server, or each and every user became a node, or they became a cloud concept. Okay. The removal of intermediaries. Okay, here, for example, such as a bank, brokers, lawyers, or payment gateway. There are so many payment gateways. There are so many lawyers who are intermediate between us and the court, the brokers for a land buying, or a bank for a transaction. So we are avoiding these type of people, okay, and these are called as removal of intermediaries. Okay, so blockchain enables direct transaction between participants and removing the need of these type of third parties. Okay, so bank, a buyer, the data will go to the bank and payment process happen at the seller. So this is the example I said for a that is called uh, faster concept. Okay, so we deposit in the bank only, not into the seller. That is not into the national highway. So we are depositing into the bank, and it will go to the payment process, and it will go to the seller. That is the national highway. Whereas in the blockchain concept, the buyer directly go to the national highway via a blockchain concept. Okay. What is the advantage? Lower transaction cost, faster processing time, reduce administrative overhead, okay, greater transparency, fewer point of failure. So these are the five major uh, advantages. That is lower transaction cost will reduce, faster processing time. The processing time is very fast, reduce administrative overhead. Okay, there is no boss there, so the administrative overhead was reduced. The greater transparency and few points of failure will be addressed. So, example, a cross-border money transfer through a traditional banking system. Okay, for this cross-border money transfer only, they will go for delimitation again, 10 years back. Okay, so this is a major thing when we go for a administrative overhead. Okay, for that we are going for a blockchain concept. This is a trustless environment. Okay, so the trustless environment does not mean participants do not trust each other. Either it means that trust is placed in the blockchain protocol, cryptography, consensus mechanism instead of a central authority. So while we are believing a human being or believing a central system, we will go for a blockchain protocol, a cryptography that is secured via a OTP or a, simple passwords uh, with a strong password with some values, okay, some hash functions like that, and consensus mechanism. There is a protocol and the consent mechanism. Consent means in between two people, they need a consent. Okay, and they need a uh, mutual understanding to carry out the data to one place to another place. How blockchain create trust? A transaction is verified by multiple nodes. A single node will not verify. It is verified by a multiple nodes. Okay. Cryptography, algorithm secure data are used. Consent mechanism validator records are used. Okay. All transactions are publicly verified. Okay. So in traditional, user trust as central authority, whereas user trust as blockchain protocol. Okay. So example, two parties who have never met can safely exchange. Okay. Today world is similar to that blockchain one. Okay. We didn't meet each other, even though in our teaching field also we didn't meet each other physically, but we are meeting through, yeah, via social media or via this type of video conferences like that. Okay, we don't have any physical attachment, but there is a uh, video conferences, that is a mutual understanding between the two parties. Okay, so via that we can easily convey our message to one another via these type of blockchains. Okay. That is autonomous operations. Blockchain system can operate automatically through a predefined rules. A smart contract, there is a contract between one party to another party, one node to another node, without continuous human interaction. There is no need of human interactions. Okay. Smart contracts. Here the word is called smart contracts. Smart contracts are self-executing programs stored in a blockchain. So there is a contract. Okay. Contract between a node, two nodes via a hash function or a OTP passwords like that. Okay. So working process, condition met, a smart contract executed, a condition, a transaction completed. Okay. So there is a condition, you have to satisfy the particular condition. So whenever you satisfy a particular condition, the smart contract concept executed and transaction completed this way. Okay. So example, an insurance smart contract may automatically release a compensation when verified conditions are satisfied. Okay. So whenever there is if you are going for an insurance, okay, or any trustable transactions. Whenever they satisfy the conditions, there is no need for a third person to believe, okay, or to trust, or to give some breath to do the particular work. If you are uh, uh, have a trustful source, it is automatically run. We have a password. For example, in a voting system also, nowadays they are saying that voting machines are hacked, but if you using a blockchain, it will not be hacked so easily because we have an OTP or we have a function to enter, and we will log that thing after we vote that particular thing. Okay, so if you want to open, we need a password with some group of people who are voted. If that particular hash function are collected together, and it is come into a single source of password. Via that password only we can able to count that particular voting systems. Okay, that is a big concept while we are going for a blockchain. So it is a good concept, but it is a costly thing. So they are not doing that in a practical manner. Okay, so advantage: automation of processes, faster execution, reduce human errors, lower operational cost, and increase efficiency. And distributed decision making. Here, decision making is very important. Okay, so we have to. The system will automatically make a decision making whether we have to share or not share. Okay, uh, so decentralized system decision are made collectively by the network participant. That's why it's a. For example, 10 students have a concept of a group, okay, and if you want to buy something, all the 10 students must satisfy or they have to say yes. Okay, if he say yes, this yes will be transferred into a password and it will be given to activate the thing. Suppose one person say no, out of 10, 9 say yes, one student say no, means the hash value will be, or the security issue will be changed. Okay, so the concept is 9 is not a value, 10 is the value. When there is a 10 students, it will trust on the particular 10 students. Okay, so this decision are made by a network participant rather than by a single authority. Okay, for example, in a 10 students, one or two students maybe have a high value of yeah, authority person. They behave as an authoritative person. They will say, yes, we will go for this one. Okay, but two or three people in that particular group, people will say, no, there is no idea. There is no money for us to buy this type of product. So we are not interested like that. If we say means, in a single authority manner, they will say, okay, you go in your way, we will go in our way, like that, they will say. Okay. So they will leave that particular two, three students, and that remaining the 7 students will buy the product. Okay. But when a blockchain concept is concerned, they have to consent the 10 participants' willingness. They have to get yes from the 10 students, and if the 10 students say yes, that particular key will be transferred and that particular key will be activated to get the data. Okay? Understand? This is the blockchain concept. So traditional, there is a central authority, he will make decision. But whereas in a blockchain concept, participants have a consent and they will take the decisions. Okay. So what is the architecture? Let's see the architecture. So each and every system will act as a node here. Okay. So computer A will act as a node, computer B act as a node B, C and D, and each and every node have a ledger. Okay. The ledger concept is, I already said, in a banking concept, the ledger concept will come. In a database, it is say log concept, log file. Okay. So what is a block and block structure? Okay. As said earlier, in a hard disk, it is a called block. For here, there is a block header and a block body. It is segregated into two things. What is a block? Okay, it is a called head. There's a hash previous. of a previous block. Okay, it's a chain concept. So block one, block two, block three, like block there. So each and every block are attached with the head via a hash function. Okay, just like I think you may study in a data structure linked list concept. Okay, data structure you have a linked list. In the linked list there is a header node and a tail node. Okay, here like that it is a head and it is a body. In the body there is a full and full transition will happen. In header it is a address for the previous block. Okay, so here only the hash previous will be work. Okay, so this is the head block head. Okay, out of the main block, they are segregated as a head and the body. Okay, in the block there is a header. Here we have a block versions. Okay, block hash, Merkle tree. Okay, timestamp, n bits and nonce. So here the previous block hash, the links the current block to the previous block, just like a linked list. Okay, the address of the previous block. There is a timestamp when it was activated. Okay, when it was updated, what updation happened. So this timestamp is very important while we are doing. Okay, the Merkle root, they represent all transition in a block. The nonce, a value used to during a mining and consensus and block versions. Okay, there is a protocol, there is a version for each and every block. Then body, block body. So it is contains a list of transaction details. What are the signature, digital signature? The digital signature in the sense that is OTP or whatever maybe we are. Okay. So what is a transaction? It's a record of activity or exchange occurred within a blockchain. Okay. This is commented the block body. So what are the components in the transaction? Okay. So it is a sender address, receiver address, and data. In a money transfer, it is an amount, and there is a digital signature, that is OTP. In our understanding, it is a OTP, and there is a transaction ID. Okay. While a bank transaction will happen via Google Meet, Google GPay, there is a transaction ID will generate a no. The people will ask the transaction ID only. Okay. So these are the five major parts in a transaction. Okay. So sender address, receiver address, amount or data, digital signature. So what is the process happen? So the user initiate the transition. The transition is broadcast to the network. That is called broadcasting concept. Broadcasting in the sense, I have to say I am initiating a transaction. Okay, it will transfer to the all the blocks. Okay, that Robinson Joel initiated a transaction. Okay, so that's called we are saying that transparency. Okay, so each and every node will understand that Robinson Joel have initiated or triggered a transaction in the blockchain. So node verifies its validity. Each and your node will verify that a particular person is launched a transaction. So verified transaction is added to the block. Okay. Now the verified transaction. Okay. Suppose I am deposited 1 lakh in a particular transaction means, so it will be verified by the all the block and it is been noted. The block is append to the blockchain. Okay. When there is a block, it is created and it is to be append into that particular chain. Okay. So for example, take it as a train. So there are so many cages, okay, or cabins. Okay. So for example, there are 12 cabin, or in a metro train there is a 12 cabin, 7 cabin, or coach in our translation it's a coach. Okay. So here it is called as block. Okay. So in a coach, in a train, there is a coach. If there is an additional two coach will come means, we have to inform the header, that is engine, that two coaches are added. Okay. So two coaches added, it will not transferred only to the engine, but also to the neighboring coach also. Understand? So this is the broadcasting concept. Okay. So nearby coach also need to know that additional one coach was added to our nearby, so that we have to connect with that particular coach. Okay. So the block is the same concept. We have to broadcast, and after getting all the satisfied thing happen, the block was connected to the blockchain society. Okay. So there is a hash function here to activate this particular transaction. That is, the hash function will convert the input of any size into a fixed length output called as hash value. Okay, so data was converted as a hash value. Okay, so SHA, there are so many concepts are called in the formatting. So it is not a plain text, okay, it's a hash text. So plain text was transferred into a hash text, okay. So in one type of hash text is SH256, okay. It says about the memory concept. Why hash is important? Even a single character changes in the data, the resulting hash changes completely, okay. Here I give one example, blockchain, and next one also blockchain. What is the difference in the two examples? So first example, I put B as a capital letter, and the second example, I put B as a smaller letter. Okay. So even single character change will be affect the entire system. Okay. So it must be broadcast to the nearby block that there is a change happened, and for that particular change, this is the password. Okay. So this is a highly secure and transparent, and each and every node will understand there is a action happened nearby. So there is a timestamp. Okay. So when it is happened, there is a timestamp. Maintaining chronological order, transition history, okay, and prevent duplication, support auditing. This type of thing will be happen while we are going for a timestamp. So this is the example. This is a date. Okay, it will be mentioned. This is a benefit ensure sequence of event when it is happens. That is Merkle tree. Okay, so there is a root, Merkle root. Okay, it is a tree. When you tilt, it is like a tree. This is the major root. From this root only, it happens to the leaf node, non-leaf node. There is intermediate node. It is also for the intermediate node, and the starting tree. Okay, so transaction T1, T2 happens. It is transferred to the hash one, and it will hash one, hash two will be combined together to say hash one, two, and the hash one, two will be go to the root as a hash one, two, three. So each and every node or each and every transaction is combined to have a root hashing thing. Okay, it is a unique digital fingerprint of all the transactions. Okay, that's why I said. So 10 students, yes, must be transferred to the root. Okay, not a single. If a single person say no, it will be affect the total transaction concept. Okay, so this is a tree. It is a hierarchical data structure that organizes large amount of transaction data efficiently. It is found by a caching individual transaction and then repeated. Okay. So what is the advantage? Physically, it's a efficient verification, reduce storage requirement, faster validation, and enhances security. Okay. There is a chain formation mechanism. Another concept is a blockchain is found by linking blocks through a cryptographic hashes. Okay. So this is the chain concept. Okay. So the steps of a chain concept, the transaction creation happened. Step two, the transaction validation happened, and a block was created. Okay. First of all, the block is created. After a block is created, it will attach to the blockchain. Okay. So simple. Understanding as a coach. So people will accommodate in the coach, and the particular coach will be added to the train. Okay. So informing the nearby coach, all the coaches in the particular train, and head node and the tail node of the particular train. Okay. So hash created and linking the blocks to the particular blockchain, and addition to the finally the block was added to the blockchain. Okay. So what are the key components of blockchain? So first one is node. There are 5 important. So node is in term it is called as computer or a device. Okay. Then next one, distributed ledger. Okay. In a banking system there is a ledger. Here it is called shared database. Okay. So node, computer, distributed ledger is a shared database, and consensus mechanism, it is a protocol. Okay. Then cryptography technique, it is a foundation of blockchain security system. There are so many cryptography techniques available. In this particular cryptographic techniques, there are so many research are going on. Okay, how to reduce the memory space of a particular cryptography security and highly secure keys can be generated. So it is a uh, very interesting area in research. Okay, then smart contracts. So it is a self-executed digital agreement between two node or two person or two blocks. So, for example, here a standard example. For example, if you are going to transfer money from a person from India to a US, okay, so you are from US, okay, how you transfer? In a traditional system, the Rabi is store the data, deposit the amount into Indian bank, okay, the Indian bank will go for the international payment networks and it will directly store it to the US bank. From the US bank only, the John can be able to retrieve the money. Okay, so there is a five layer of transaction happen here in a traditional system, but whereas in a blocking. Okay, what happens? Ravi submit the transfer request to this bank. Bank verifies his account. Transfers are passed to the multiple intermediaries. Each intermediary charge a fee. Okay, there is a fee for a charging, and receiving bank credits the John's account. The process will take 2 to 5 days. Okay, so what is the problem here? High transaction fees occur. Okay, that is called charge. Okay, slow processing happens depends on a bank limited transparency service unavailable if a central banking system fails. Okay. Whereas blockchain based centralized system, so Ravi will initiate the transaction. Okay, first of all Ravi will initiate the transaction. What will happen in the blockchain network? The transaction will broadcast to the blockchain. The node verify the transaction using a consent mechanism. Okay, the validity is added to the block, and the block is append to the blockchain. Simply four transactions in a blockchain, and the John receive the fund directly. Okay, so all will happen in the blockchain. There is no intermediator, there is no boss here, no single authority here. It will directly Ravi will be able to transfer to the John. Okay, this is the concept of blockchain. Okay, faster transaction, lower fees, no intermediary banks, transparency records available 24. So importance of blockchain in modern computing. So improved security, the transparency and the trust will be happened here. Okay, elimination of intermediaries will happen here. There is data integrity here. Okay, then finally, there is an automation through smart contracts, wide range of applications. There are so many applications are available while using the blockchain. So these are the major applications used via this blockchain concept. One is cryptocurrency, digital payment system, banking and financial service, healthcare is very useful, supply chain management. Okay, there is no what is it say intermediators. Okay, he will transfer the data directly to the purchaser from the seller. Smart contracts, IoTs, digital identity management, education, voting system, I already said what happens in the voting system, and agriculture and food sector. So there are so many sectors. These sectors are very much resource in a research field. Okay, you can do lot of research work in the particular domain using this blockchain concept. Okay, I hope you may understand what's the thing. Just to recap, what we studied today via this blockchain. So, what is blockchain? Basic blockchain. Okay, and what is a traditional centralized system? Okay, so as I can recap it. Okay, so this is a centralized system. Okay, then we study about distributed system, and finally we learned about what is centralized system, what is block. Okay, so I hope you may learn something about what is blockchain and what are the applications available in the blockchain. Okay, So what is a field or a domain which are used via these blockchain concepts? Okay. So thank you one and all for listening this lecture today about what is blockchain. Okay. So thank you, ma'am.
And expertise have greatly enhanced our understanding of blockchain technology and decentralized systems. To deliver the vote of thanks, I invite Mrs. Drishya, Assistant Professor, Department of Information Technology.
On behalf of the Department of Information Technology and the Association of Information Techomasa, I could like to express my sincere gratitude to everyone who contributed to the success of today's professional society event on blockchain, the backbone of decentralized systems. First and foremost, I extend our heartfelt thanks to Dr. M. Robinson Joel, Associate Professor, Department of Computer Science and Engineering, KCG College of Technology, Chennai, for delivering an insightful and enlightening session. His valuable perspectives on blockchain technology and decentralized systems have greatly enhanced our understanding of this rapidly evolving field. Despite his busy schedule, he graciously accepted our invitation and shared his expertise with us. We are truly grateful for his time, knowledge, and inspiring interaction. I could also like to express my sincere gratitude to our respected chairman, Dr. A.C. Shanmugam sir, President Engineer Arun Kumar sir, Dean Student Affairs and Head of the Department Dr. N. Kanya ma'am for their continuous encouragement and support in organizing academic events. My heartfelt thanks goes to faculty members of Department of Information Technology for their valuable support and efforts in making this event a success. I could also like to thank all the participants for their enthusiastic presence and active involvement. Once again, I extend my sincere thanks to everyone for being a part of this event. We hope that the knowledge and insights gained today will inspire us to explore and innovate in the rapidly evolving world of technology. Thank you all.
So thank you, ma'am.
Thank you, sir. With this,
Shall
we
I?
come to the end of today's professional society event on blockchain, the backbone of decentralized system. Thank you all for your valuable presence and participation. Thank you, sir.
Thank you. Thank you.